Hello, everyone. Sorry I have to be gone today, traveling with the soccer team as they compete in Missoula Sentinel. So we're going to be having to do a recorded lesson. Yesterday we were looking at section 1.4, which is on division of whole numbers as far as the homework is concerned. For that section, you can hold on to it, and then next Tuesday when we're back, since Monday is Labor Day, I'll look over both of those. So just hold on to those until next week. Okay, so starting 1.5, we were looking at order of operations is what this is on. Order being talking about in operations, a sense, operations we're referring to the operations of math being multiplication, division, addition, and subtraction. So that's what we're looking at today. As far as the starters are concerned, the starters I'd like to look at are areas and volumes, since those occur a lot in technical trades. Area of a square. Well, area of any box shape is always length times width, but for a square, length and width are the same. So this is just 22 times 22. So I get 22 times 22. I'm going to get 2 times 2 is 4 times 4 again. Now I carry my 0 down because I'm really multiplying by 20 in this second 2. 2 times 2 again, I get 4 and 4, and I add all of those together, and I get 484 square feet for the first one. So 484 square feet. For the second one, it says 1.3, but it actually should be 13 feet for each length, width, and height because it's a cube. I have 13 by 13 by 13. If I want to find the volume of a cube, it's just length times width times height. So I get 13 times 13 times 13. In order to do that, I'm going to do each of those calculations. Carry this over here maybe. Right here. So I'll do 13 times 13 once. So 13 times 13. I get 3 times 3 is 9. 3 times 3 is, or 3 times 1 is 3. Add my 0. And I get in total, it's 169. Now I'm going to take 169 and multiply by 13 because 169 is just the area of one side of that cube. I get 3 times 9 is 27. 6 times 3 is 18 plus 2 is 20. And I get 3 times 1 is 3 plus 2 is 5 by 0. I'm just going to copy down the number. So I get that the area, or volume, I'm sorry, of that cube is 2,197 cubic feet. Always important to write the units down, because if you're reporting an answer to your boss for a report, they're going to want to know what the units are, especially when we start working with different units here in a couple other chapters. We're going to do the lead-in here in a second, but before we do the lead-in, we need to talk about order of operations. Order of operations becomes important when I talk about something like, what if I had this statement, 7 maybe minus, or maybe let's do 7 plus 6 times 3. Some person might think, hey, maybe math works just like English, and I read left to right in English, so I'm going to do operations left to right. So they might think, I'm going to do 7 plus 6 first, and then multiply by 3, and I get 7 plus 6 is 13. 13 times 3 would be 39. It's a valid idea. Another person might say, well, why can't I just do the multiplication first? So if I have 7 plus 6 times 3, maybe I'll do 6 times 3, get 18, do 7 plus 18, and then I end up with 25 instead. The problem, as you can clearly see, is I get two different answers for those expressions, and that can't happen if I'm going to be eventually working with formulas, because the formula should tell me how fast something is spinning or how deep something is drilling. So if I'm going to get consistent answers, I need to be getting the same answer. So in math, we've determined an order in which we're going to apply the operations, and that order is we're going to do parentheses first, because we're implying grouping that those should go first. Those are important. Then we have exponents. Then we have multiplication and division, but those are actually tied. We work those two left to right. So if there's multiplication and division going on in an expression, we do the leftmost one first. And a similar idea for addition and subtraction. Those are tied as well. We work those left to right. Some grouping symbols, those refer to the parentheses mostly. So parentheses is a grouping symbol. There's also brackets if we have nested expressions, we might have parentheses inside parentheses. So to denote a difference between those, we're going to use brackets. An example might be if I had something like, oh, maybe 3 plus 7 minus 2 or something like that. I wanted to put brackets, maybe communicate. I want to do that rightmost one first, something like that. And the last grouping symbol is kind of the most interesting of all of them, and it's a division actually. Whenever I have something like 7 divided by maybe 6 plus 8, there's really a grouping going on down here, even though it's not written. It's saying I need to do the 6 plus 8 first. So a fraction division bar actually groups everything on top and everything on bottom together. The challenge, now that we know the order of operations, is this, and it's actually the lead-in. If I were here, I would ask for some volunteers to pick some numbers. The goal is I want to pick 5 numbers, or pick 6 numbers really, and we want to use the first 5 once and only once, and the operations of mathematics to get the 6th number. And I'm going to pick numbers between 1 and 20. So here I go. This is completely random. Maybe I'll pick 12, 2, 1, maybe 18, and I don't know, 8. And then the magic number I'm trying to hit using those 5 right here might be the number 3. So I want to use operations of addition, subtraction, multiplication, or division to get the number 3. And I can only use each of those red numbers once and only once. I have to use each one, but I can't use it more than once. I can use addition or subtraction or multiplication or division more than once, but I can only use the numbers once and only once. So let's pause the video now, maybe give it 2 minutes or so, maybe even 3, to see how many different ways we can get an answer of 3. So I'm going to pause it now, and I hope you do as well. Come back after people have tried it. Okay, welcome back. Hopefully we had some people getting some really clever solutions for this. The one that I came up with was the following. So I did 12 plus 8 minus 18 all divided by 2 plus 1. The reason this works is because 12 plus 8 is 20, minus 18 is 2. Now I have 2 divided by 2 plus 1. 2 divided by 2 is 1 plus 2. That's not going to work. Shoot, I was trying to get 3. Let me think for a second. So I'm going to pause it now, come back. See, this is what happens if you work too quickly. Okay, perfect. So I gave it some more thought, and I think I have a way to get it to 3, so let's try it out. It's good to always check your work. That's what the last one showed. So on attempt 2, I'm going to try this guy. 18 minus 12 divided by 2 minus 8 minus 1. I think I used each of them once and only once. And here we go. 18 minus 6 minus 8 minus 1. 18 minus 6 is 12, minus 8 minus 1. 12 minus 8 is 4, minus 1. There, finally got 3. Awesome, cool. It's a game I like to play, and actually it turns out whenever you pick 6 random numbers between 1 and 20, there's like a 99.9% chance you can get at least one solution. So here is our orders of operation. You might also hear the expression. It's a mnemonic device called please, excuse, my dear Aunt Sally. Maybe she had some beans at lunch. But it reminds us that we do parentheses, exponents, multiplication, and division tied, addition, subtraction tied together when operating on an expression. So here's an example. If I look at example 1, I'm going to pick out, I don't see any parentheses, I don't see any exponents, so I'm going to do my multiplications first. I see 2 multiplications. I see 4 times 20, and I see 8 times 5. 4 times 20 is 80. 8 times 5 is 40, plus 4.8. If I add all of those things together, I get 124.8. Simple example of orders of operation. Let's have you try the following ones down here. Try checkpoint questions 1 and 2. So pause the video now for a minute. Shouldn't take any more than that. Come back and see how successful we were. Okay, let's give it a look. For these guys, there's only 2 operations going on, multiplication and subtraction. Multiplication's first, so I have 25 minus 18. Subtracting 18, I get 7. Cool. Over here, I have division and subtraction. Division's first. 56 divided by 8 is 7. 7 minus 4 is 3. Shouldn't be any troubles. These ones down here are a little bit of challenge questions. I think originally on the notes right here it has 22. I want you to cross out that 22 and put a 10 here. The goal is I want you to insert parentheses somewhere in these two expressions to make one of them 10 and make the other one negative 42. Because if you don't put any parentheses in there right now, I'll show you what it equals. 8 minus 4 divided by 2 times 3 plus 2 squared. If I don't put any parentheses in there, the first thing I do is this guy, my exponent. So I get 8 minus 4 divided by 2 times 3 plus 4. Did my exponent. Now I do multiplication or division left to right. This is the first one I do because I do multiplication and division left to right first. So I end up with 8 minus 2 times 3 plus 4. Now I do my multiplication, which is 8 minus 6 plus 4. 8 minus 6 is 2 plus 4 equals 6. If I don't put any parentheses in there, I just get 6. I want you to pause the video now, take 2 minutes, see if people can figure out where the parentheses would need to be located. So one equals 10, the other one equals negative 42, and we'll come back and go over it. So pause the video now, please. Okay, welcome back. When thinking about this, the reason we use parentheses, we have to be reminded, is to do operations earlier than they normally would have occurred. Well, the ones that occur late in the process are addition and subtraction. So I want them to occur earlier in an expression. I need to put parentheses around them. So my best guesses for where these occur before I even start are going to be right here and right here. And so my first guess is let's try the first one. Let's put parentheses around 8 minus 4. And then it'll make this 4 divided by 2 times 3 plus 2 squared. And then I say, okay, I got division first going left to right. So I have 2 times 3 plus, well, 2 squared is 4. 2 times 3 is 6. 6 plus 4, hey, that equals 10. It does its job. The second one is, again, I want to say, let's make addition occur earlier than normal. So now I have 5 in that parentheses. So I have 8 minus 4 divided by 2 times 5 squared. I do my exponents. 8 minus 4 divided by 2 times 25. Working left to right, I do my division first. 4 divided by 2, that is 2. So I have 2 times 25. Now I do my multiplication. I have 8 minus 50. And indeed, 8 minus 50 is negative 42. So it does its job. A little bit challenged, a little critical thinking. Cool. Let's try some ones that have some grouping symbols already in them. So here I look, order of operations again. PEMDAS. Say do parentheses first. 14 minus 3.8 is 10.2. Now I have 10.2 times 5. Might be tough without a calculator unless I remember that 0.2 is actually a fifth. So now I have 5 times 10 and 1/5. Well, 5 times 10 is 50 and 1/5 times 5 is 1. So this is actually 51. So I picked it because it was doable. This one right here, B, is a great example of what I was talking about with that other unique grouping symbol back here. Whenever I have a fraction division bar, I'm grouping the top and bottom first. So this is really saying I need to do 27 minus 3 grouped together first, and 4 plus 2 grouped together first as well. 27 minus 3 is 24. 4 plus 2 is 6. Now once I've simplified them up top, then I can divide and get 4. Last one is if I have these nested brackets and parentheses inside one another, I'm going to do the parentheses innermost ones first. 11 plus 8 is 19. Then I do the bracket of 35 minus 19 is 16. And 4 times 16 is 64. So those are some of the more complicated examples of order of operations. With those now behind us, try these 2 checkpoint questions. And I want to make a note with number 4, be careful. 6y over the quantity x plus 1 does not allow us to split that into 2 different fractions because there's this grouping down here of x plus y. Those are grouped together. I can't split those up until I've simplified as much as I can. So try that. Note that when it says evaluate, it means to find the value, and it's going to give us 2 things to substitute in. Where I see x, I'm putting 4. where I see a y, I'm going to put a 5. So pause the video now, come back in 2 minutes after everyone's had a chance to try it, and we've checked our answers and compared with our. Perfect. Welcome back. Let's go over it. I'm going to substitute 5 in for y. So this becomes 5 times 19 minus 4 in for x squared. 4, and so the parentheses tell me focus in on there first. So I zoom in on there, and I work inside the parentheses, and I see an exponent. So 4 squared is 16. Now I have 5 times 19 minus 16 is 3. 5 times 3 is 15. So there's my first answer. Second one, I substitute in, and I get 6 times 5 up top. On bottom, I get 4 plus 1. And there's this implied grouping right here, up and on top and on bottom. Says we need to simplify those first. Up top, I get 30. On bottom, I get 5. 30 divided by 5 is 6. Cool. Sounds good, sounds good. Last one is kind of a challenge. This is a, it's called like a progressive payment system. And this can occur in a lot of different scenarios. It might occur in like a texting or a cell phone situation where they charge you per minute, and if you go over, then those minutes start to become more expensive as you hit different brackets of usage. So here's the example. It's for water conservation. This is actually really important in California right now where they're having water shortages. So the more you use, the more they're going to charge you. So to encourage water conservation, a water district began charging its customers according to the following monthly block rate system. So if you read this table carefully, it says for the first 20 HCF, and if you read in the bottom left, it says HCS. HCF stands for hundreds of cubic feet. For the first 20 HCF, it's $3 per HCF. For the next 30 after that, so between 21 and 50 HCF, it's $4 for each 100 cubic feet. And then after that, in that third block, it costs $5 for each extra hundreds of cubic feet. And I want to know how much 72 HCF would cost. So if I'm going to use 72 HCF, I need to use the first 20 at $3 per one. So 20 times 3, the first 20 costs $3 each. And I need to use the next 30 in that second block at $4 each. So if I just stopped right there, I would be using 50 HCF for the month. But I'm not using just 50, I'm using more. I'm using 22 extra ones to make 72 total, and those last 22 are going to come from this third block. And in that third block, they're being charged $5 each. So this would be plus 22 extra at $5 each one. That's called a unit rate. Now I do order of operations. I do my multiplication first. This is going to be 60 plus 30 times 4 is 120. Plus 22 times 5 is 110. I add all of those up. I get 180 plus 110 equals $290 for that month. Quite expensive for that water usage. You can see why they're trying to conserve it. That is it for the lesson on order of operations. Just recall that we're using PEMDAS, and it becomes really important because a lot of the times you will use a lot of formulas in the technical trades, and they expect you to know what the orders of operation are to get the correct answer. So the homework for today, we are on day 6 on the assignment sheet in section 1.5. If you look at your assignment sheet, it is page 51, and questions A, 1, 3, 5, 7, 11, 19, 35, and 37, and then B, 1, 3, and 5. Those ones in B are more likely application questions, so spend some extra time on those. That's it. I will be back next week, and thank you very much.